Hello everyone. I hope you all are doing very well. And in this session, we are going to see again one of the most important problem that how do LSTM, that is long short-term memory networks, generally exhibit lower mean squared error compared to the traditional recurrent neural networks and convolution neural networks in certain application. So what is the main reason behind it? So we are going to focus on it. So basically, the reason why LSTM network often yield lower MSE, that is mean squared error, compared to the traditional way, that is recurrent neural networks, RNNs, and CNN, that is convolution neural network, in certain application, that lies in the unique architecture and capabilities of LSTM to effectively handle the sequential data and capture long range dependencies. So the reasons can be, one thing that is superior is handling long-term dependency. So LSTM is able to handle long-term dependencies because they are specifically designed to address vanishing gradient problem. Basically, in the traditional methods like RNN, they face vanishing gradient problem. So they cannot remember that much longer view, or you can say that when they are going to learn, then there might be the thing that on processing the sequential data, the capabilities of RNNs are like they are not going to remain, they are not going to remember long-term dependencies. But this vanishing gradient problem can be handled effectively by LSTM due to its gating mechanism, and that is one of the reason that it may give the lower MSE, right? So this ability allows LSTM to capture dependency across longer time steps, which is crucial for type tasks like time series predictions or sequential modelings, right? And the second reason can be that memory cell architecture. So long short-term memories have a more complex internal structure compared to the traditional recurrent neurals, and they consist of memory cells that can be maintained in a hidden state and cell state, which can be updated and modified over time through gating mechanism such as input gate, forget gate, and output gate. And this architecture enables long short-term memories to selectively retain important information while filtering out the noise and irrelevant signal from the data set. So due to its complex internal structure, this could be the second reason. And one more reason could be the reduced vanishing gradient problem that we have discussed, that because of its gated architecture, gated mechanism, gate control the flow of information and allow gradients to propagate more effectively during training. And as a result, LSTM can learn from longer sequences without loss of gradient information. And fourth reason could be performance on time series data. So in task involving time series data or sequential data with long range dependencies, long short-term memories often outperform traditional RNN and CNNs due to their ability to retain information over extended periods. And this makes them particularly effective for tasks such as speech recognition, machine translation, and sentiment analysis in NLP. So basically, um, these are some of the important key area because of the extra advantage ability of LSTM over RNN and CNN. One more reason could be effectively sequence modeling. So LSTM excel in modeling sequence where the temporal dependencies are complex or span across many times. So the memory cells and gating mechanism allow LSTM to capture integrate patterns in the data, which leads to more accurate predictions and lower MSE, right? And one more reason could be LSTMs are preferred over traditional RNN and CNN in certain applications because of long range dependencies, maintaining information over extended sequence, and mitigate issues like vanishing gradient problem. And this results lower MSE and improved performance, right? So on tasks that require effective sequence modeling and analysis, however, the choice of neural network architecture should ultimately depend on the specific characteristics of the data on which we are working and the requirement of the task at the hand, right? And the domain of the problem, right? So basically, the purpose of these lectures are just to get know that how this evaluation matrix could perform, what are the key concepts of this evaluation matrix, and while doing your research, what should you need to keep in your mind, right? So this is just lectures we are completing because of the purpose of that you can if beginner in this field, then you can effectively do your study, right? And you can follow us on the following social media links. All the links are mentioned in the description section. Stay tuned and subscribe for more such video lectures. Have a very nice day, guys. Jai Hind, Jai Bharat.